correlation coefficient, or you can say Carl-Pearson coefficient. We used to use the correlation coefficient to measure the strengths of the relation between two variables. Here in this example, I'll try to show you how to find or to compute the correlation coefficient between two variables like x and y. Then, in this example, I have some values for x, like x equals 0, x equals 1, and x equals 2. The corresponding y for 0, y equal 1, the corresponding y for 1, the corresponding y for x equal to 1, y equal to 3, and again the corresponding value for x equal to, it will be how much? It will be 5. Then to compute the correlation coefficient R, first of all you should do what? Yes, you should insert those data from the small table, this one, inside the big table, this one. Then let's start. Give me the values of x equal what and what and what? X equal to 0 and 1 and 2. What about the corresponding y? Y equal what and what and what? Y equal 1, after that 3, and then what? And then 5. Then try to complete now this table. Just multiplication. Try to multiply x with y. Let's start. Multiply this x with this y. 0 multiplied by 1. Make multiplication between them. The answer will give me 0. And when you multiply 1 by 3, make multiplication between them. The answer will be 3. And when you multiply 2 by 5, the answer will be how much? The answer will be 10. Correct. After that, to complete this column, you should do what? You should multiply x by itself to produce x squared. Then x squared, it's mean I will multiply x by itself. Then again, those my x. Let's start. 0 multiplied by 0, it will give me 0. And 1 multiplied by 1, it will give me 1. And 2 multiplied by 2, it will give me 4. Correct. The next one, y squared. Y squared, it's mean I will multiply y by y. Then now multiply y by itself. 1 multiplied by 1, it will give me 1. 3 multiplied by 3, it will give me 9. After that, 5 multiplied by 5, it will give me 25. Now the table completed. Then after that, try to find the addition of each column separately. Let's start to do that. Then the addition of this column, when you add them together, 0 plus 1 plus 2, it will be 3. The next one, when you add 1 plus 3 plus 5, it will give me 9. The next one, when you add 0 plus 3 plus 10, it will give me 13. By the same way, 0 plus 1 plus 4, when you add all of them together, the answer will be 5. The last one, the last column, 1 plus 9 plus 25, when you add them, they will give you how much? They will give you 35. And now you should tell me n equal what? N, it represents the number of pairs of data. How many data here I have? 1, 2, and 3. Then in this case, n equal to what? N equal to 3. Then now I will substitute about those numbers, all of them. I will take them and I will substitute inside this formula. This is the formula, or this is the rule of the correlation coefficient. Then let's do that together. Then R equal to, let's start. First of all, the n, the value of n. N here equal what? N equal to 3. Then replace this n and put what? And put 3. Multiplied by what? As you can see, summation xy. This is summation xy. Summation xy equal what down here? 13. Then I will put here 13. Minus 2 brackets, between them multiplication. The first one, it contain what? Contains summation x. Summation x, it's mean the first column. The summation of the first column, as you can see, 3. Then here I'm going to put 3. The second one, summation y. This is summation y, or this is the column of y. The summation of the column of y, it's 9. Then here you should put what? 9. Down I have one root, and this root contains 2 brackets, between them multiplication. Let's start down. First I have n. N I know it. N equal to what? N equal to 3. Then 3 multiplied by what? Summation x squared. X squared here inside my table, the summation of x squared just 5. Then put here 5. Minus bracket all square. Inside this bracket I have what? I have summation x, just single x. Then summation x, the first column, equals 3. Then I'm going here to put what? To put 3. Let's continue. The next bracket, it has what? N inside. N, I know it, equal to 3. Multiplied by summation y squared. Y squared from my table equal how much? 35. Minus bracket all squared. Inside this bracket, I have summation just y. It's mean the second column. The answer will be how much? The answer will be 9. Then now I will try to enter all of those numbers inside my calculator, and I will press equal. Directly the calculator will give me the result, and the result will be what? Will be number. Just number. But we have some notes, they are related to this number. What is the notes? If this r equals 0, that's mean we have no correlation. If this r equal to 1, that's mean we have something is called perfect correlation. But in general, the values of r, all the time it will be between -1 and 1. Like r, it can be suppose 0.1. It can be 0.7. It can be -0.5. But it cannot be 5, because as I said, the value of r, it should be between what? Between -1 and 1. Not less than -1 and not more than 1. Any number between -1 and 1, it's mean correct. Like if the calculator suppose give you 9, r equal to 9, that's mean your solution wrong, and you should repeat again, because the answer should be between -1 and 1. Also, if the calculator suppose give us this number, r equal to 0.97, then what I'm going to do, I will go to search here inside this table. 0.97, this value lays in which interval here? Yeah, lays here between 0.9 and 1. That's mean I'm going to put this comment. I have very high positive correlation. Then I should write here, in this case, I have very high positive correlation. But if suppose r equal to this number, the next one, r equal to -0.93, then again I will go to search about which interval contains this number, this interval, the negative interval, as you can see. Then because -0.93, it lays between -0.9 to -1. That's mean I'm going to use this also comment, but I will take the -1. Then I should say what here? Very high negative correlation. And what about this case? This one, r equal to 0.35. Let's search about this. This value 0.35 will be here. It will be between 0.3 and 0.5. Then the proper comment here, what? Low positive correlation. Then in this case, I have what? I have low positive correlation coefficient. Okay? Then this table will help us to what? To give our comment. Then in this case, when you compute this value by the calculator, it will give you 1. Then for that, the comment will be what? I have in this case, perfect correlation. Positive 1. Here I would like to show you some graphical interpretation for those two examples, example 2 and example 3. As you can see, for this case, I have relation between x and y. How that? When x equal to 0, y equal 1. When x equal 1, y equal what? 3. And when x equal to y, it will become what? 5. Then we can say what? We have same direction between x and y. How that? As you can see, when you increase the value of x from 0 to 1 and from 1 to 2, what will happen to y? Y also will increase from 1 to 3 and from 3 to 5. Then both of them, they are going to increase. That means they have the same direction. But the opposite of that happen here in example 3. Look, x equal what? X equal to 0. It will increase to be 100. It will increase to be 200. But the opposite of that happen with y. Look, y it will start from 30. After that, it will decrease to be 15. After that, it will be what? 0. Then in this case, they have what? They have opposite direction. That's mean one of them will increase, but the other one will decrease. Okay, this is will affect where in the correlation. If both of them, they have the same direction, then R in this case will be positive value. And if they have different direction or opposite direction, that's mean when you compute R it will be what? It will be negative value. Okay? Now I would like to do what? To make the graph between x and what? And y. Then as you can see the first pair, when x equal to 0, the height y will be 1. Then at 0, I have height here how much? I have height here 1. Okay, at x equal to 1, I have height 3. Then at x equal to 1, the height will be how much? Will be 3. Then this point. The first one, it was this one. Nice. The next one, at 2, the height will be 5. Then at point 2, you should go up till height how much? Till height 5. Then as you can see, I have how many green points now? I have 3 green points. Now, for those 3 green points, is it possible to connect them by one line like this or not? Yeah, possible. The name of this line, the regression line. At the same time, as you can see, all the green points, they are lays on this line. Then in this case, we have what? We have perfect correlation. That's mean R equal to what? R equal to 1. Perfect correlation. Let's now discuss the second one, the second example, the opposite direction. I will consider x as a distance and y the fuel, the amount of fuel. Like when I go distance 0 by my car, the fuel at that case will be full 30. Let's sketch that. Then at distance 0, I have fuel 30. Okay. After that, when you go distance 100 kilometer, the fuel will be 15 liter. Then at distance 100 kilometer, the fuel will decrease to be how much? To be 15 kilometer. That's mean my point here. Okay, when you go again to distance 200 kilometer, the fuel will finish in your car, then it will be 0. Then at 200 kilometer, no fuel at all. That's mean no height. Then again, how many points here I have? I have 3 points. Now try to connect them together. When you connect them together, they will give you this line. The name of this line, if you remember, the regression line. Then as you can see, all the green points, they are lays in what? They are lays in this line. Then I have in this case also what? Perfect correlation. Perfect correlation coefficient, but the value of that R will be what? Will be -1, because the data, they are going down. They are decreasing. Now let's discuss those different cases. As you can see in this case, case number 1, all this data, they are going to increase. Here also, in case number 2, the data, they are going to increase. And also in case number 3, the data, they are going to increase. Regard that, the correlation, it should be what? Positive. Positive, and then what? And then positive. Also, when you draw the regression line for those data, as you can see, all the data, they lays on the regression line. That's mean R equal to 1. Then I have, as you can see, perfect correlation. But in this case, when you draw the regression line, some data, they are away from the regression line. Then in this case, R not equal to 1. It should be less than 1. Here R equal to what? To 0.9. As you can see in the graph, the data, they are not on the regression line, but they are very close. They are very close to that what? To that regression line. Regard that, we have here high correlation. Why high? Because the data itself very close to the regression line. What about the case 3? In case 3, when you draw the regression line, you will discover what? In this case R, the regression line equal to 5. And when you go to the graph, you will discover what? Those data, they are little bit away, far away from what? From the regression line. They are little bit far away from the regression line. Look, in the case of 0.9, the data very close to the regression line. But what about the case of 0.5? They are little bit far away from the regression line. If you reduce this number, suppose R equal to 0.2, what will happen? When you draw the regression line like this, you will discover the data far away. Okay? Far away from the regression line. Check now those cases with me. Look, the data here, they are going down. Here also they are going down. Here also they are going down. That's mean I have here what? Negative case. The correlation should be negative when you compute it. Okay, R equal to what here? Negative 0.5. R equal negative 0.9 and R equal to what? To negative 1. Try now to draw the regression line. When you draw here the regression line, all the point will be on the regression line. Then the value of R equal negative 1. This is perfect. Okay, when you consider this case 0.9, when you draw the regression line, you will discover what? All the data, they are very close to that what? To that line. Regard that, we rename it high. Okay, for this case, when you draw the regression line, you will discover the data, they are far away from the regression line. Regard that, look, R equal negative 0.5. And also we consider it what? We consider it low. Finally, for this case, R equal to 0. That's mean I have no correlation at all. At the same time, we don't have any behavior to those data, no relation between them. You cannot consider them they are increasing, or even you cannot consider them they are decreasing. Then in this case, we have no correlation at all between the data. Thank you.